All right, good evening, everyone. So my name is Jian. You can call me Wee in short. I'm doing PhD in the School of Engineering, and I'm going to talk about thermal design and management for 5G and future network. Apparently, I'm going to try to make it less engineering, so that's going to sound simple for you. So slide, please. So 4G network nowadays is already good enough for us to make video calls with our family and friends and upload videos to Instagram and TikTok. But sometimes the connection quality may not be the best. What if we're all connected to 5G, 6G, or better network? What if our video calls with our loved ones can always stay connected even though we're traveling from one state to another? That is great, but that will require way more base stations. But what's the difference, though, between 4G and 5G? If I'm a 4G base station, my signal can travel all the way to the end of this hall. But if I'm a 5G base station, my signal could probably travel up to the first row of the audience. So to get all of us connected to 5G or more, we'll need more base stations. More base stations means a higher demand in a more compact and space-saving design. This top right corner over here is a sample radio unit of a 5G base station. And I would like to invite all of you to imagine that this entire floor is a circuit board. Each and every one of you is an electrical component. So when I start operating this 5G base station, all of you will start to heat up, but in a different speed and temperature. So Andrea is probably going to heat up pretty fast, and we'll have the cameraman and you over there at the top right corner will heat up pretty fast as well. And we call these people hotspots. And they will create a phenomenon we call thermal segregation. To save up more space, I'm now going to tilt this entire circuit board to vertical. The hotspots now remains, but remember, hot air rises. So now we're going to have a temperature gradient creeping up to the top. Some of you will now start to overheat and you'll probably break down. And that's the exact problem that my research is trying to solve. This bottom right corner here is a vapor chamber, my solution to overheating. It can be as small as my palm and as thin as the wrapper of your chicken wrap. This passive device do not have any moving parts, and it does not require any electricity to make it work. If I slice that open and we look into the cross-section, vapor chamber is filled with liquid. And when it is in contact with the hot component at the bottom, this liquid evaporates. And when the vapor is in contact with the top surface, which is cooler, it's going to then condense back into liquid. The vaporization and condensation cycle is the one that's going to cool down the hot electrical component. Ideally, there'll be no more thermal segregation, no more temperature gradient, none of you will overheat, and your video calls with your loved ones will now always stay clear, fast, and connected. My name is Jian. Thank you for listening.